introduction. So, hi everyone. Today I will present our work on ImAxes, which is about immersive axes as embodied affordances for interactive multivariate data visualization. So this work has been done with my colleagues from Monash University in Australia, Tim Dwyer and Kim Marriott, and also Andrew Cunningham and Bruce Thomas from the University of South Australia. So, multidimensional and multivariate data are ubiquitous. Take something as simple as wine, for example. Wine can be characterized by various data attributes or dimensions, for example, the amounts of chlorides they contain, the density of the wine, the acidity, or the amount of residual sugars it may contain. But actually, wine can be described by many more dimensions. So let's say if you're a wine data scientist and you want to explore a large collection of wine data, well, you'll need a tool to make sense of this potentially big and multidimensional data set. So to support the exploration of multidimensional data, we propose a novel visualization tool that we call ImAxes. So in ImAxes, the user is immersed in a virtual reality environment in which the data dimensions are represented by those 3D axes that the users manipulate in space. So each axis in this scene corresponds to a data dimension. Here we see a user wearing a HTC Vive, so actually it's me, and he's exploring the wine data by building visualization using bimanual interactions with the controllers. So in this video, the color coding corresponds just to the type of wine, so pink is for red and yellow is for white wine. So ImAxes is a modeless visualization system. The user explores the data by directly manipulating those axes in the virtual environment, and ImAxes creates automatically 2D and 3D visualizations according to the axis layout in space, without the need for the user to invoke menus. So exploring and understanding multidimensional data is a subject covered by the field of visual analytics that we just had a presentation about just before. And visual analytics basically uses interactive data visualization to convey information visually to the user to support their reasoning. So one very common and traditional way to visualize and explore multidimensional data is to use a sketchplot matrix, like this one. So the sketchplot matrix displays all the 2D combinations of data dimensions in a matrix form. With this type of visualizations, user can, at a glance, visually detect patterns such as trends, correlations, or clusters in a data set between two specific dimensions. So parallel coordinate plots are an alternative way to visualize multidimensional data, and it's also a very common way to visualize multidimensional data. So the axes that you see horizontally positioned on the visualization correspond to the data dimension. And each data point in the dataset is represented by a line segment that crosses all the dimensions. So those two techniques are widely used in information visualization and visual analytics to provide the user with a visual overview of multidimensional datasets. So recently, more advanced methods have been designed to allow the interactive creation of this type of multidimensional data visualizations. So those methods let the user create hybrid visualizations, where scatter plots, for example, can connect to parallel plots. So users can get more insights and by using those combinations of visualizations. So the flexible axis concept, for example, allows the user to draw axes on a canvas, a bit like in Illustrator, for example, and create the corresponding visualizations, and then explicitly linking them together. So the aim of this type of method is to provide more freedom to the user to explore multidimensional data by creating their own data visualization, hybrid data visualizations. So this type of system uses the axis as the core object of interaction to build hybrid visualization and kind of to drive this very user-centered multidimensional data visualization exploration. So we wanted to take a step further with the axis-based interaction concept by creating a virtual embodied representation of the data dimension axis that present affordances to the user in the virtual environment. So in ImAxes, the notion of embodiment refers to the definition of Dwyer, which basically tells us that with embodied interaction, users can pick, manipulate, and arrange artifacts, like tangible objects, for example, or elements on a user interface in order to create meaningful visualizations and hence understand better the data. So here's an example of embodied interaction. So embodied interaction is, for example, used in air traffic control. For example, in France, air traffic controllers still use paper strips that are tangible representations of flight routes data. So what they do is they arrange those paper strips on a strip board that helps them building a mental model of the state of the traffic. So that will help them to, for example, create sequences for landing or takeoffs. So the concept of affordance in ImAxes, of course, refers to the perception of what can be actuated or manipulated in the system. So the typical example is the handle on the door that is perceived as an actionable item to open the door. So in ImAxes, the axes are the embodied affordances of the data dimensions that the user can grab, manipulate, put together, assemble, put everywhere in the space to build the visualizations in this virtual reality environment. Okay, so the starting point of the design of ImAxes is the manipulation of those axes in the VR environment using, well, simple and natural gestures. Our first step was sketching how the system should behave when the user manipulates the axis simply with the hands. And we began with very simple gestures and very simple visualization to start with. So, for example, to build a 2D scatter plot, the user can simply grab two axes dimensions, put them together like this, perpendicular, and ImAxes should display a 2D scatter plot. Well, another simple way to extend this to a 3D scatter plot is simply to put a third data dimension axis perpendicular to the 2D scatter plot already built. So a simple way to build a parallel coordinate plots is to simply hold two axes parallel together and next to each other. So when they get close together, ImAxes should display the parallel coordinates. So one of the challenges of designing ImAxes was to design a system that responds coherently to the user interactions when manipulating and positioning, but not only the axis, but also the visualization in the virtual environment. So the aim was to provide a fluid and modeless interactive system to support, well, this free creation of simple visualizations to export the data, but also all sorts of connected visualizations to help the users understand the relationship between the data. So to ensure this, we developed a very simple spatial grammar that recognizes which type of visualization ImAxes should display when users put the axis in space. So basically, at a high level, the ImAxes grammar follows 3 steps. The first step is about to recognize the direction and the layout of all the axes. So to do that, the grammar has operators and symbols. We have 4 simple operators that tells us the direction of an axis, if a set of axes are orthogonal or parallel, or if they're in contact with each other. And then it produces symbols, S1, S2, and S3, which correspond to 1-dimensional, 2-dimensional, and 3-dimensional visualizations. So once the ImAxes grammar has produced the symbol, it produced the corresponding visualization. And finally, there's a rule that connects the visualization together when they're in a certain distance. So, for example, on this slide, A and B are within the threshold of linking. So if the users put them close together, visual links appear between the 2 visualizations. So that's the basic backbone behind ImAxes. So I'm just going to go through the rule very quickly. The first rule of the grammar recognizes a standalone axis with its corresponding data dimension and creates a S1 symbol that contains simply just a single axis. And in this case, ImAxes shows histograms of the values of the dimension. So when we start ImAxes, basically it creates just freestanding axes that are not already positioned next to each other. And it just displays histogram visualizations on each axis. So the first rule to create a S2 symbol requires that 2 axes are in contact and perpendicular together, as I showed in the sketch. So that's how it works in the system, actually. Then ImAxes produces a scatter plot when the axes are put perpendicular together like this. So we also added a rule in the grammar to extend this concept to build manually scatterplot matrices, and basically we can extend the set of vertical and horizontal axes, and ImAxes displays, recognizes the layout and displays the scatterplot matrix accordingly. And we also have another type of rule that creates 3D visualizations, such as a 3D scatterplot. So basically, this rule is about assembling an S1 symbol and an S2 symbol, which is pretty straightforward. If you put a third axis perpendicular to the visualization, you create this 3D scatterplot. Okay, so with this simple spatial grammar, users can easily reproduce familiar visualizations. So histograms are given for free because when you load ImAxes, it just shows like the distribution of each dimension. Then it's pretty easy to assemble the layout for 2D and 3D scatterplots. As I showed you, we can easily create scatterplot matrices, and by putting axes parallel together, we can also just manually create those parallel coordinates plot. And we can also do this type of kind of advanced linked visualizations that has been seen before in the literature of information visualizations by simply linking 2D scatterplots, putting them next to each other. So on top of the production of these familiar visualizations, ImAxes offer freedom to the user to build non-standard visualizations as well that correspond to their own exploration process. So this is an example of a circular parallel coordinates plot. So basically here we can place the axes in a circular way, and they connect to create these 3D scatterplot. And we can put at the center another dimension. And what it shows us, it's a type of a one-to-many linked visualization, and basically it's a novel approach to perform focus and context operations. With facet linking, it's possible to arrange 2D scatterplots in a hierarchical way, like this, like a tree. So this example here, well, it shows a tree of piled scatterplots that presents two different paths for the red and the white one of our dataset that go through the same dimensions of axes on the left and on the right side. So here, basically, the user can view the different paths that the red and the white one follows for the same type of attributes, and there is kind of visual saliency that appears from this type of arranged visualization. So with an initial exploration of the possibilities that ImAxes offer, we found many more emergent visualizations. So I invite you to have a look at the paper to see all the other examples that we found, such as this hybrid between a parallel coordinate plots and a 3D scatter plot. And when it's interactive, it's even more compelling. So to support basic visual analytic tasks, we developed simple interactions such as filtering per axis. So here we have handles on the system that springs out on the axis, that springs out when we bring the controller next to an axis. And we can, for example, filter out some data. We also implemented a scaling operation that uses another handle. Basically, when you have a very skewed distribution on an axis, you can rescale this data dimension to show like what actually the data looks like. So when ImAxes starts, the full collection of axes are arranged in rows, a bit like on a shelf, if you like. And to work with an axis, the user simply duplicates it by putting it out of the shelf, a little bit as if you were like grabbing a book out of the shelf. That's the metaphor. And to delete axis from the workspace, well, you can just throw it away on the ground and it disappears. It's pretty funny, but yeah. Okay, so beyond our defined interactions with the system, we found that the affordances of the virtual environment coupled with our defined grammar provide interesting emergence of new interactions when we explore the data. So an interesting example here is the management of occlusion. So occlusion is a common problem with parallel coordinates plots. And in ImAxes, users can simply grab the axis like this and twist the parallel coordinate plot, and it results in this animation that shows basically the lines that are hiding behind each other. So we didn't think about creating this type of interactions when we first designed ImAxes. It just appeared as a as if you like, an emergent interaction in the system. We found another interesting emerging interactions that we call axis swiping. So here we see the user grabbing the type of wine, so obviously red and white, and he swipes across all the other axes. So swiping in that case provides the user with a fluid method to quickly explore the relationship between the axis in his hand and all the other axes. So it results in this kind of continuous apparition and disparitions of parallel coordinate plots, and it gives like a very quick idea of the relationship between the two axes. Okay, so the focus of our paper was to design a visualization tool based on the embodied axis interaction paradigm. Well, ImAxes work quite well with a dozen of dimensions, but obviously some data sets, and actually the majority of data sets, have hundreds or thousands of dimensions. And for this, we need to explore dimension reduction techniques to allow the user to handle large, like highly dimensional, multidimensional data sets. Also, to have a more complete visual analytics tool, ImAxes need to support more types of visualizations, such as surfaces or other types of statistical visualizations or geographical visualizations using maps, for example. And finally, we want to integrate more analytics methods and algorithms, for example, clustering or classification or other layout examples to maybe improve a little bit the layout of the connection between the linking facets. Okay, so in conclusion, in this work, we contributed ImAxes, which is a new tool to explore multidimensional data. So our initial exploration with a potential user, we found that it's a kind of a playful tool, and it's engaging. Some people even say it's fun, so it's pretty interesting for multidimensional data exploration. And we also contribute this axis-based spatial grammar, this pretty simple axis-based spatial grammar to recognize automatically which type of visualization the system should display. So in terms of future work, and that's kind of big, we are actually designing a user study to explore how users create those visualization in the virtual environment, but also what type of novel visualizations they create according to their task, which is very important. And we are also very, very interested in how they use the space around them, how they position the visualization around them, how they recall, how they use the spatial memory. So thank you very much for your attention. So come and have a look at the demo tonight. I'll have ImAxes working with an Oculus Rift, so if you're curious, just come. Okay, thank you very much.
Hi, my name is Junhyub Lee from KAIST, South Korea. Thank you for the presentation. It's a very cool looking system. And I have a couple of questions that are kind of interlinked. So how would you produce other types of charts? I think you mentioned it in future work, but do you think that your spatial grammar would extend to include those other charts, because they right now look kind of simple and might not be extendable to more complex charts? And my second question is, what do you think is the main advantage of using VR in creating these charts, and how do you plan about performing a user study to confirm the main advantage of using VR? Okay,
thank you for this set of questions. It's actually very pertinent. So the first question is about how to support more charts with this simple grammar. So yes, obviously, as you said, we use just simple visualizations as scatter plots and parallel coordinates plots. There's definitely going to be it's going to be a challenge to for example, create modelessly more type of charts, but we're slowly working on it. Yeah, but we are working on it. And I think the second questions were about why VR is interesting to use for multidimensional data visualization. Well, we think that there is this case of using the space around you. So the takeaway message that I wanted to convey is this kind of axis-based exploration, which already exists on 2D computer screens, and basically we want to expand this canvas to the virtual environment. And I'm really sorry, but I forgot the third point. Yeah, the user study. Actually, yeah, we're still thinking about it. So we could compare the process of exploring a new data set with, for example, a very standard tool like Tableau and our tool, or we could do a more longitudinal study because ImAxes require training, because it uses a new environment, and so on and so on.